Everyone sees the sheet of graph paper on your notes. Okay. First thing today, we're going to talk about similar figures, and you're going to find out there's a relationship between the sides and the areas and the perimeters if two figures are similar. So the first thing I need you to do right now, we're going to make rectangles. On your graph paper right now, can you make a 3x4 rectangle for me? 3x4 rectangle. Length and width, one's 3, the other's 4. Do a 3x4 rectangle for me. And in your group, by yourself, however you work best, find the perimeter and area of that rectangle for me. Find the perimeter and area of your rectangle. And that will be referred to as your original rectangle for the rest of this activity. That's your original rectangle. Everyone have your perimeter and area of it. Okay, go back to your chart, please, on page 1 of your notes. Under original, just remind yourself that this was a 3x4 for me. Remind yourself, hey, this was a 3x4 rectangle. All right, can we get a superstar here to start us off? No? Oh, there we go. 26. Perimeter. 14. And how about the area? 12. I heard him. What are you doing back there? Was that your number? Then zip it. Okay. Everyone all good? All right, now our job is to make similar rectangles, and this will be a class decision right now. So I need to make a rectangle similar to the 3x4. So same scale factor, a half, multiply by 2, 3, 4, whatever you want to do, but the length and the width have to be similar to the 3 and the 4 that you give me. So your decision right now, oh boy, 12, your decision. 6x8, there we go. So let's do a 6x8 right now. Now, if you want to graph these, you can. If you want to figure out the perimeter and area without graphing, I'm fine with that too. Okay, because some people may give me some extreme numbers. So if you want to graph it, that's fine. If not, that's fine too. I'm fine either way. But I do need the perimeter and area from somebody. So my 6x8, what's my perimeter and what's my area? Don't screw it up. All right, let's rock and roll now. When you're ready there. Oh, 21, here we go. 28, area, 48, there we go. Can I have another similar rectangle to the original? Big job, number 5, big job. Oh, here we go. 9x12, you kids. It's all right, Ella, it's fine. Thought you were gonna go crazy. 9x12 rectangle, perimeter and area. Three, when you're ready, perimeter. Nine by 12, perimeter. When you're ready, Jake, let me know. Number 3, perimeter, 9x12 rectangle. And how about the old area? 108. We're all good so far. All right, is anybody going to change this up or just keep it going with the pattern? 13. Oh, I'm devastated. 8. Oh, Colin.
About 1.5 and 2.
Ooh, doing a little division. Nice. 1.5 times 2. I like it. And how about the perimeter and area of that one? 10. It is. Thank you. All right. Yes, Teddy. What is the relationship here? Why'd we do all these? All right, here we go. First thing, similarity ratio. Darn it, we've heard this term all year long. Similarity ratio is if two figures are similar, that's the ratio of two corresponding sides. So if we're going to go first rectangle to the original, so everyone look at our 6x8 to our 3x4. What is our similarity ratio? Take two corresponding sides. What's the ratio? 6 to 3, 8 to 4. No matter what you go in, it's going to be a ratio of 6 to 3 or 8 to 4. What's that ratio in? 2 to 1. So there's the similarity ratio from 1 to the original. Now take their perimeters. Perimeter of rectangle 1 was 28. The original was 14. Also, whoa, 2 to 1. And how about the ratio of the areas? Not 2 to 1, but 4 to 1. All right. We can't establish a pattern after one example, so now let's compare 2 to the original. Compare 2 to the original. What's the similarity ratio of rectangle 2 to the original rectangle? All right, you're up. 1. Here we go, Meg. Come on. 3 to 1. Here we go. Now everyone look at their perimeters, 42 and 14. Their ratios? 25. Their ratios? 3 to 1. Now take their areas, 108 to 12. What do you got for me, 9? 9 to 1. Anybody establishing a pattern maybe? If I know the similarity ratio, how can I find the ratio of the perimeters and the areas? One more just to solidify it. 19, similarity ratio of rectangle 2 or 3 to the original. 1 to 2, yep. Look at their perimeters. 7 to 14 reduces down to, 30. Top dog over there. 1 to 2. And finally, 25. How about the areas? 1 to 4. All right, kids. Have we established a pattern yet? If we know the ratio of two corresponding sides, what do we know about the perimeter ratio? It's the same, Dan, right? It's the same. Can it be said for the areas, though? It's not the same, but could I find it? If you know that similarity ratio, what do you do to it to get the ratio of the areas? Square it. We just talked about it. Let's write it down now. All right, so first theorem we just talked about, S1 over S2. What do you think S is going to be? Oh, similarity ratio, side ratio, yes. That's the similarity ratio. If you know that ratio, it's the same as look back if you need to. It's the same ratio the what are in. Perimeters are in. P1, I'm going to put P for perimeter, over P2. 1 and 2 are the figures. So P equals perimeter ratio. I made this pretty small. All right, and then we also established a second theorem, which says if I know the similarity ratio, I can get to the area ratio. But is this true, kiddos? Is that true right there? No, it's not. The similarity and the areas are never equal. Adjust that for me. What do I need to do to the similarity ratio? I need to square it, yes, before I know the area ratio. So S is going to be, I'm sorry, A area ratio. Only if they're similar, only if they are similar. All right, if you need to take a deep breath, go ahead, take a deep breath here before we get finished at a fast pace. Here we go, let's use these facts now. Number one, I have a pair of similar figures. Can anybody tell me what their ratio of their sides are? 4 to 5. That's the only two sides I gave you that correspond is 4 and 5, right? So the similarity ratio is 4 to 5. What are we looking for? Ratio of the perimeters and ratio of the areas. All right. Once again, what was the side ratio? 4 to 5. First one I'm going to ask then, what's the perimeter ratio? Don't yell anything out. What's the perimeter ratio going to be if we know the side ratio is 4 to 5? 24. No, good try. Didn't get me today. 29. 4 to 5 as well. Why, Dan? They're always the same. Now, I want to make sure you understand this right now. Am I saying the perimeter of the smaller one is 4 and the perimeter of the bigger one is 5? No. Here's what I'm saying. If we found the perimeters, put them over each other, reduced, what would it come out to be? 4 over 5. All right, do not get confused. I am not saying the smaller rectangle has a perimeter of 4. That's ridiculous because one side is already 4. And I'm not saying the bigger one has a perimeter of 5. I'm just saying it's in some ratio 4 to 5. We're all good. All right, what about the area ratio now? Not 4 to 5. Not 4 to 5, but I can use the 4 and the 5. How, 19? Square it. So I'm going to say 4 squared over 5 squared. So the ratio of the areas for those two rectangles would be 16 over 25. Again, hey, guys, am I saying 16 is the area of the smaller one? No, I'm just saying if we happen to find the areas, put them over each other, it reduced down to 16 over 25. We're all good. Oh, Teddy, yes. How? Go ahead, simplify it. 16 over 25 doesn't simplify to 4 over 5. No number goes into 16 and 25. You're maybe taking the square roots in your mind, maybe? Okay, that's not how we reduce around here, right? You're better than that. Okay, next time you have a thought, don't say anything. All right? Okay, this is driving me nuts. How small this is. All right, 2, same question. Little tough part at the beginning is what side matches up with the 3 I gave you on the smaller triangle. That's what your job is right now. All right, you got to make sure you know what the 3 matches up with because that gets this whole ball rolling. Remember, if you want to figure out what side it matches up with, darn it, put the angles on top of each other. Put the congruent angles on top of each other. So what's the 3 match up with? Oh, 18, the 3? The 5. There we go. So now we have our side ratio, don't we? 3 to 5. Side ratio is 3 to 5. What about the ratio of their perimeters now? 22, ratio of their perimeters? 3 to 5 as well. They're always equal. And now how about the area ratios? 26 area ratios. How'd you get it, Connor? 3 squared and 5 squared. So I got 9 over 25. Questions there? All right, now we're actually going to use these ratios to find the actual perimeters and areas. Actually, in a second, not right now. Sorry. 2 figures are similar, 2 regular hexagons. Areas are 8 and 32. What about their side ratio now? So one area is 8, the other area is 32. Hey guys, look, I'm looking for this now. I'm looking for S1 over S2 now. That's what I'm looking for. So kind of going backwards. I know how I got the 8 and the 32, but how do I go backwards to the similarity ratio? Any thoughts here? Oh, 8, any thoughts?
We gotta find the square root of
If I got there by squaring, once again, Colin, how do I undo it?
square root.
Square root. So I'm just going to go to my calculator right now. Square root of 8 divided by the square root of 32. And leave that as a nice clean fraction. So square root of 8 over square root of 32 reduces down to a side ratio of 26 when you're ready. Keep going. You can keep reducing. You're correct. Radical 2's cross out. You got 4 over 2. Or 2 over 4, excuse me. 1/2. Yep. Everyone okay getting 1/2? Should be able to do it right in the calculator too. Okay, you guys have fraction templates. You can do radical 8 over radical 32. You guys that don't have fraction templates, just put it in parentheses. You should still get 0.5, which is 1/2. Stop me now. We all good? All right, what about the two circles with areas of 128 pi and 18 pi? Again, I'm finding the similarity ratio or the side ratio. So once again, we're going to take the square roots. 128 pi, the square root of 128 pi over square root of 18 pi. If you prefer to cancel the pi's out before you put them in the calculators, go ahead. And we end up with 13. What do we end up with the ratio? One job. 7. What do we have? Eight over 3. Yep. Stop. I have a question for this honors level class. We just found the side ratio, and the figure was a circle. Let me say that again. We found the side ratio for two circles. I didn't know circles had sides. They don't, but it could be the ratio of the circumference. What are things I can measure? I can't measure sides in a circle, but I can measure radii, diameters. So this would be the ratio of the radii, the diameters in the circle, okay? Because we don't have any sides. Any questions so far over these last two word problems? Meg, you're right here? Okay. Everyone else good? Any big plans today? Bless you. Okay, we'll move on. Month and a half, big Regents exam coming up, huh? Okay, we got the shorter sides of a rectangle are 6 feet. Shorter sides of a similar rectangle are 9 feet. The area of the smaller one's 48. What's the area of the larger one? All right, so I got two rectangles. The side of the smaller one's going to be 6 feet. And the side of the bigger one's going to be 9 feet. And what else do I know? The area of the smaller one, 48 square feet. What is the area of the larger one? Hey, you guys know the area of the side? I mean, the ratio of the sides? What is it? 6/9, 9/6, whatever direction you want to go here. So that's the ratio of the sides, and you can reduce that if you're feeling warm inside. And then I'm told the area of the smaller one's 48, and we need to find the area of the larger one. Is that true? Is this ratio true? Let me clean it up a little bit. I'm embarrassing here. Is that a true ratio right now to solve? I hope not, because I did not get anything through to you today then. Because what are you telling me right now? You're telling me the side ratio, and what's this represent? And the areas are always equal. No, somebody adjust this proportion for me, please. Make it correct now, because it's not right now. The sides and the area ratios are never the same. Somebody adjust it for me. 6, you want to help me adjust it? Square which side? 9/6, or if you're feeling crazy, how else could I adjust it instead of squaring this side? Square root the other side. If you're feeling really nuts, I might avoid that, but hey, you want to get after it. But yes, square the sides. Now you can get after it to find the area of the larger one. Bless you. You all right today, guys? Jeez. I feel like I should be handing out like wipes or something. Well, we got X already. You guys are waiting for me. Sorry. 29. Dan. I'm still waiting. Thank you. How you been, Dan? All right? Doing all right lately?
Yeah.
Good. Good to hear. How's life treating you? All right?
Yeah.
Okay. Good. I was talking to Dan.
I was talking to myself.
Okay. All right. Do what you got to do. Everyone good on the 108 before we get to this beast of a word problem? Yes, Benita. She is a gardener, a farmer maybe, I don't know. Big Al is reserved for what? Tests and quizzes. Yes. And did I announce already that next unit you will find the identity of Big Al on one of the quizzes or tests? Yes. Like what he looks like. What he looks like. Yes. Big Al will be revealed on one of the next unit's quiz or tests. He is making an appearance on Thursday. He is going to be painting a garage, and we need to help him out finding how many square feet is his garage. He needs the paint, and then how many paint buckets he needs to. It's a decent size. It's made up of a couple figures page, okay, that you're going to have to break down, all right, to find the area of. Yep. He's got a garage door that's not going to be painted. That's going to come in. That's going to throw some of you for a loop. Yeah. Yep. Part of the garage has a door that's not going to get painted, so you guys got to factor that in. It's going to be a good time on Thursday. All right, here we go. Benita is planting some crops. Any suggestions on what she plants? Corn, carrots? Do we just assume it's vegetables? Maybe could be some fruits, strawberries. Did you just say bacon? Bacon? I didn't know that could be grown. Now, is that on like stalks of bacon, like the corn, where I can just peel it right off and... Okay. Now, how do we start growing them? Just plant a thing of bacon right in there? Cooked or uncooked bacon plant? And plant them and just let it grow? What's that?
Kindergarten, a children's farm. Oh. Children's garden.
So children just spring out from the ground.
Yeah. Like that one movie.
Once again, we just go right to the extreme in here. Okay, anyway. All right. All right, let's get going. Oof, all right, sorry I let you guys go off there. Yep. All right, she plants 2 rectangular fields, each with side lengths of a ratio of 2 to 3. Now, I want to clear this up right now. When it says each with side lengths of 2 to 3, that's not the corresponding sides. That means 2 to 3. They're in some ratio of 2 to 3, the length and the width. Okay, so that's what that 2 to 3 represents. Okay, the length and the width are in a ratio of 2 to 3. Okay, that's how I know they're similar. All right, so the ratios are in the length of 2 to 3. Here's what we really need. Each dimension of the larger field is 3.5 times the dimension of the smaller field. Okay, so whatever the length is here of the bigger one, it's 3.5 times the length of the smaller one. Everyone good? Okay, so for instance, somebody, here we go. Just give me a random length right now. 12, just give me a random length for the smaller one. 6, sure. What do you want, 6 inches? Sure, 6 inches. That's a pretty small field. The other one would be 3.5, whatever 3.5 times that. It doesn't matter the numbers. I'm just trying to get you guys a feel for what the problem is looking at right now. Everybody good? Okay. And then it costs, the seeding of the smaller one costs $8. How much is it going to cost to seed the larger one? Okay. Well, let's first talk, because we've done perimeter today and we've done area. We're going to seed, right? And we're not seeding around the outside. We seed the field, which is the inside. Everyone, the seeds, everybody good? Why are we just promoting this? Like it's a good idea. All right, so we got the seeds inside. So this is going to be a perimeter or an area one? Area. So we know that whatever the side ratio is, we need to square it before I get to the areas. What is the side ratio here? And this is why I tried to clean this up at the beginning. What is the side ratio here? Well, it's going to be 3.5. It's 3. This side is 3.5 times bigger than this side, correct? Okay, so it's not going to be 3 to 3 or 2 to 2. They're not in the same ratio, right? It's not going to be 2 inches, 2 inches, 6 inches, 6 inches. Everyone agree? All right, how much larger is the larger one than the smaller one? 3.5. So I'm going to go 1 over 3.5, but do what with them? Square them. And now where's the 8 going to go? Since we're talking area, $8, where's it going to go? Is that $8 for the smaller or the larger field? Smaller, so it's going to go across for the smaller one, $8. How much is it going to cost? And this is why you just don't think, oh, 8 times 3.5. That's how much it's going to cost. It doesn't work that way. $17 when you're ready. How much is it going to cost to seed this larger field? Thank you. Questions? Don't be surprised if there is a random vote out tomorrow as you walk in the door. All right, just throwing that out there. I will be here today and tomorrow after school if you want to go over anything. Might be a good idea to start getting all those formulas together because I'm not giving you a reference sheet with them on them. All right, so you start getting formulas.